Today we will see a very interesting topic in probability, that's called addition theory of probability. Let's say we have a random experiment, the sample space of which is S. Let there be two events A and B. From set theory we know that n of A union B, that is the number of elements in A union B, is equal to number of elements in the set A plus number of elements in the set B and number of elements in A intersection B. A union B is event A or B and A intersection B is A and B. If you are having problem, you should go to my video on set theory. I have given you the link in the description box and see why this is called event A or B and why this is called event A and B, how n of A union B is equal to NA plus NB plus NA intersection B. These things have been dealt in set theory and then in probability theory. So you can go to my earlier videos or you can see the link in the description box and check those videos and understand them. We'll start from here in this session because this is a bit advanced course. So this is what we get. Now let's divide the numerator and denominator on both sides by ns, that is the number of elements in sample space S. So this is ns. Now from definition of probability, we know that NA union B by NS is the probability of A or B. That is, either of the event has occurred. The probability that either of the event has occurred. And this is probability of A, this is probability of B, and this is probability of A and B, that is A intersection B. So this is the problem. This is addition theory of probability for two events. Similarly, so first of all you should learn this by heart. You will be solving problems. Similarly, if we have three events, if we have three events, then what will be the formula for it by addition theory of probability? Let's see. Meanwhile, if you have not subscribed this channel, kindly subscribe the channel. Also, I request you to share the video and also I request you all to write your feedback in the comment box so that I am able to improve my videos as per your comments. So do give your feedback in the comment box. So we were saying, what if we have three events? So what will be the probability of A or B or C? See, again, from N of A U B U C, that is A union B union C, from there you can get this. I'm directly writing the value. You can verify it. You can do one thing. You can take this as one set and this as the second, and from the last statement that we had given, you can find this out. I'm giving you directly because we will be using this in our problem. So this will be equal to PA plus PB plus PC. That is probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of C intersection A plus probability of A intersection B intersection C. So this is the formula if we have three events. Okay? Learn this by heart. We'll see these formulas when we will be solving examples. Let me give you one more observation on this. Let's say I'm drawing a Venn diagram to explain. Let's say this is the universal set U, that is the sample space S. And we have two sets, A and B. we know that this portion, this is given by a minus b. This is a minus b. B has been subtracted from this. Similarly, this portion, this is b minus a. And this portion, this common area, this is a intersection b. Clear? Also, this is the portion. If we say b dash is what? Out of this all part. So if a intersection b dash, this is the area, a minus b. How? This is b. This complete portion is b dash. So if we say a intersection this complete portion, then this will be the part. This is the common part. So this is a intersection b dash. Similarly, this is b intersection a dash. Now from here we derive some formulas. Basically, the formulas are not so important as is the concept, as is the logic. So we'll see it. From here we can see that a can be written as a minus b, this portion, plus a intersection b, that is union a intersection b. So this can be written as a minus b, this portion, plus union, we are in set theory, union a intersection b. Okay. Therefore, probability of a will be, this union will become plus, this you have studied in set theory. So this will be probability of a minus b plus probability of a intersection b. From here we get a very important derivation, that probability of a minus probability of a and b, that is a intersection b, can be written as probability of a minus b, or a minus b is also probability of a intersection b dash. This is a useful formula which we will be using in our examples. Similarly, for b also it can be written p of b minus p intersection a intersection b can be written as p of b minus a, that is p of a by intersection b. So these are some useful derivations that we will be using in our examples. So let's see examples. So the question is written on your screen. It says A, B, C. There are three events A, B, C which are mutually exclusive. Then it says probability of B is given by 3 by 2 of probability of A, and probability of C is equal to half of probability of B. This is the situation. It says find PA. See, since these are A, B, C, since these three events A, B, C are mutually exclusive, this means P of A or B or C is equal to PA plus PB plus PC. All other terms in this equation will be zero, all intersections, because they are mutually exclusive. And this is the sample space A, B, C, all taken together. So this is the sample set. This will be 1, probability of this will be 1. Therefore, PA will be, probability of A will be equal to 1. This is 1 minus PB minus P of C. So this is 1 minus PB. PB is 3 by 2 of PA. And this is half of PB. Okay, let's write like this: 1 minus 3 by 2 of PA, and again this is half of PB. So this will be half of PB, that is 3 by 4 of PA. So what we'll get? We'll get 1 plus 3 by 2 plus 3 by 4 of PA बराबर 1. What is this? Let's see. 4, this will be 4 plus 6, 6, and this is 3. So this is 6, 4, 10, 10 and 3, 13. So this is 13 by 4. Therefore, this implies PA will be, probability of A will be 4 by 13. Okay. The question is on your screen. It says probability of A is 3 by 7 and probability of B dash is half. From here, let's take out the probability of B. This will be 1 minus PB dash, that is half. Okay. It says probability of A dash intersection B dash is equal to 1 by 14. So it says prove that A and B are mutually exclusive. How can we prove that? We can prove A and B are mutually exclusive if probability of A intersection B is 0. So let's find out. We have PA, PB, and we have this thing. Okay. So PA union B. What is this? You can see from set theory, from De Morgan's law, A union B, complement of A union B will be A dash intersection B dash, that we have been given here. Therefore, you must have learned about De Morgan's law. If not, go back to the video on De Morgan's law and see that. So A union B complement will be A complement intersection B complement. So this can be written as this is the complement of A union B. Therefore, this will be the probability of 1 minus PA union B. This is equal to this. So this is equal to 1 minus PA union B. So from here we get PA union B is 1 minus 1 by 14. That is 13 by 14. Okay. So let's. Now we have the value of A union B from this. So PA union B, that is 13 by 14, is equal to PA, that is 3 by 7, plus PB, that is half, minus PA intersection B. This is what we are interested in. If this is equal to 0, then they are mutually exclusive. Let's see. PA intersection B is equal to, we have taken this side and then this minus this. So this will be 14, 7 to 6 plus 2, 7, 7 minus 13 by 14. Now see, this is 13, 13, so this is 0. Since this is 0, this means A intersection B is equal to 5, empty set. Therefore, these two are mutually exclusive sets. Okay? The question is on your screen. It says, we have a basket in which there are 4 green, 6 black and 7 white balls. So total there are 7 plus 6 plus 4, that is 17 balls. So in a basket we have 17 balls and one ball is taken out at random. One ball is taken out, this means others are mutually exclusive. Fine, taking out green, taking out blue, taking out white. So these events are mutually exclusive. You are taking out only one ball. So you cannot take 2 balls at the same time. You got it? There are 17 balls, you are taking out only one ball. That is, if the probability of taking out a green ball was this and probability of taking out a black ball was this and probability of taking white ball was this, then all these 3 events are mutually exclusive because we are taking only one ball. This is the first point, that the events are mutually exclusive. Okay. Now it says what is the probability that the ball taken out is green or black? So how we will find out? Very simple. See, probability of green or black or white. This is the sample space, this will be 1. And since they are mutually exclusive, this will be equal to probability of green plus probability of black plus probability of white. Okay. So the question is, what is the probability of getting green or black? Let's see the probability of getting a green ball. We have 4 green balls, so 4C1 by 17, total is 17. 17C1, this is the probability of getting green. What if this will be? This will be 4 by 17. You can see factorial 4C1 will be factorial 4 by factorial 1 by factorial 3. So you take out 4, this will be 3, 3, 3. So this is, when you have 1, it's only n. NC1, that it will be n only. So this is 4 by 17. And second was black. So probability of getting a black ball is 6C1 by 17C1. So this is 6 by 17. Now the question is, what is the probability of getting green or black? So GUB, this will be equal to probability of green plus probability of black. So this is equal to, I'm writing it here, this is equal to 4 by 17 plus 6 by 17. So this is 10 by 17. So this is the answer. We didn't need this equation. I thought the question must be so complex, but this is a very simple question. So this, the probability of getting green or black is this plus this. So this is 10 by 17. The fourth question is, the probability of horse A winning the race is 1 by 3. And the probability of horse B winning the race is 1 by 5. So it says, what is the probability that either of the two horses win the race? That is PA union B. So either A or B wins the race. We know that PA union B is equal to PA plus PB minus PA and B, that is PA intersection B. But this is a race and only one can win the race. Therefore A and B are mutually exclusive. If A wins, surely B will lose, and if B wins, A will lose. So these two are mutually exclusive events. Therefore PA intersection B is equal to 0. So the question is the probability that either A or B wins, A union B. So this will be equal to 1 by 3 plus 1 by 5, because this is 0. So this is 8 by 15. Okay. And the second question is, within this question, that find the probability that neither of these two win. Some other horse wins the race. So this means the question is A union B complement. Neither of the two win the race. What this will be? This will be 1 minus P A union B. This is 1 minus 8 by 15. That is 7 by 15. Okay. The question is, two cards are drawn from a pack of cards. Pack of cards says 52 cards. So it says two cards are drawn. What is the probability that the two cards are red or they are queen? So we have two events, A and B. Let's say A is the event. This is question number 5. A is the event that the two cards are red. The two cards are red. You'll have to understand this properly. And B is the event that the two cards are queen. The two cards are queen. So these are two events, and what we have to find? We have to find PA union B, that is either of the two events happen. Let's see what is the probability of this. The two cards are red. Let's say this is PA. How many cards are red in our pack of cards? Out of 52, there are 4 suits and 2 suits are of red color. So 26 cards are red. So if these two are red cards, this means they have been taken out from those 26 cards, and out of total 52 by C2, 52 C2. So this is the probability of A. 2 cards coming from these 26 cards which are red, and 2 cards coming from the whole pack. This is 26 C2 by 52 C2. What this will be? This will be 26 by factorial 2 factorial 24. And what is this? Factorial 52 factorial 2 factorial 50. 2 cancels. What we will get here? This will be 26 into 25, and this will be 52 into 51. So this is the probability of A. What will be the probability of B? It says the 2 cards are queen. How many queens are there in the whole pack? There are 4 queens. One for diamond, one for club, one for spade, and one for heart. So we'll be selecting from these 4 cards. So 4C2 by 52C2. This will be again like the same. This will be 4 cross 3 by 52 cross 51. So this is this. Now, out of these 4 cards of queen, 2 are from red. So this is A intersection B, and what it will be? PA intersection B. How can we write what is PA intersection B? That is, the 2 cards that have been selected are actually red only. 2 cards that are queen are red only. So 2C2 by 52C2. So this will be factorial 2 by 2, that is 2 by 52 cross 51. Therefore, what we want? We want PA union B, that is PA plus PB minus PA intersection B. PA union B, this or this, so this will be 26 into 25 by 52 cross 51 plus this 4 cross 3 by 52 cross 51 minus this minus 2 52 cross 51. You can do your calculation. What is the value of this? The answer will be 285 by 2652. So this is the answer. Our next example is, the question is, 2 dice are thrown at the same time. What is the probability that the number that we get on the first die is an even number, or what is the probability that the total is 8? The first die plus second die is equal to 8. So again, this is A union B. Let's see what is PA. First of all, let's see what is A, set A. So what will be the set? It will be 2, 1, then 2, 2. So first one 2 and 1 to 6 on the second. This, then 4 on the first die, 4, 2, 4, 3, this one. Again 6, 1, 6, 2, 6, 3 and so on. So this will be the set A. An even number on the first die. So what is NA? It is 6, 6, 6, 18. What is the sample space when we are throwing 2 dice? What will be the sample space? It will be 1, 1 1 1 2 1 3 1 4 1 5 1 6 2 1 2 2 2 3 2 4 2 5. So this way ns will be 36. 6 into 6 36. This you know. Set B is when the addition of the two, the sum of the two numbers on the two dice is equal to 8. So what will be those numbers? 1 plus 6, no, not possible. So it will be 2 6, then 3 5, then 4 4, then 5 3, and then 6 2. So these are the possibility. 4 4 cannot be repeated because you cannot have the same element in a set. So number of elements is 5. So NB is 5. But we see A intersection B has also certain number of elements. So A intersection B will be having even number on the first die and the number on the second die such that if the sum of the two will be 8. So this is 2 6. This is not even. This is the number 4 4, and then this 6 2. So NA intersection B will be. So we have all the figures now. What we'll do, we'll get the probability of A union B, that is A or B. P A union B is given by probability of A, that is NA by NS, plus probability of B, that is NB by NS, minus NA intersection B by NS. So what we have, 18 by 36 plus NB. What was NB? It was 5 by 36. There were 5 elements. So 5 by 36 minus NA intersection B, that is 3. 3 by 36. So this will come to 18 5, 23 minus 3. That is 20 by 36. So this will be equal to 10 by 18 or 5 by 9. Okay? This is a very good question. It says the probability of A passing the examination for IT is 0.5 and the probability of both A and B passing the examination is at the most 0.3. That is P A intersection B is less than equal to 0.3. This is A and B both at the most. That is this. Okay. The question is, can PB be equal to 0.9? So let's find out what is the value of PB. We say PA union B is equal to PA plus PB minus PA intersection B. PA is equal to 0.5, then this is PB, and this is less than or equal to this thing. So the maximum value can be 0.3 or less. If less, then this will be greater than or equal to. So at the maximum value 0.3, this will be equal to this. Otherwise, if this reduces, if the value of this P intersection A intersection B is lesser, we'll have A union B greater than this value. So this is greater than equal to 0.2 plus this. This is the value. This is what we get from this equation. Now, what can be the maximum value of this? For any probability, we know that the maximum value can be 1. So let's say at maximum, this will be equal to 1. I'm writing here. This means PB, that is probability of B passing the examination, will be less than equal to, this is less than equal to 1 minus 0.2, that is 0.8. So at the most PB can be 0.8. So it cannot be 0.9. This is the answer. Our next question is, it says 20 tickets are numbered from 1 to 20. That is, each ticket has a number. So 1, 2, 3, 4, 5, 6 and so on up to 20. and one ticket is drawn at random. Out of these 20 tickets, one ticket is taken out at a random. So what will be the sample space? We are taking one ticket at a time, so it will be 1, 2, 3 and so on up to 20. This is our sample space. How many events are there in this sample space? It is 20. Okay. The question is, what is the probability that the ticket that has been drawn, its number is divisible by 2 or 5? That is, we have to, if we say, let's say A2 is the set of elements which are even in number, that is the ticket numbers which are even numbers. So there will be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. What is NA2? Number of elements? 10. And let A5 be the tickets, that is the elements are those tickets, the number of tickets which are divisible by 5. So they are 5, 10, 15 and 20. So there are 4 elements in this one, and A5 4. Now we see that some elements are common between A2 and A5. What are those? A2 intersection A5. See, 10, 20. These are common. So this is 10 and 20. This implies MA5 is 2. Clear? I am writing it here. We have NS equal to 20. We have NA2, that is the ticket which has an even number. This is N10. This is NA2 is 10. Then NA5, that is divisible by 5, is 4. And this number of elements in A2 intersection A5 is 2. So let me rub this. Now the question is, what is the probability that either the number is divisible by 2 or divisible by 5? That is, the number is an even number or divisible by 5. That is, the question is asking what is PA2 union PA5? This or this? How will we get? That will be equal to PA2 plus PA5 minus PA2 intersection A5. This will be the formula that will be applied. Let's see. So what this will be? PA2, that is equal to NA2 by NS, that is 10 by 20, plus PA5, 4 by 20. 4 by 20 minus NA2 A5, A2 intersection A5, this is 2. So this is 2 by 20. This will be 10 plus 4, 14 minus 2, 12, 12 by 20. 4, 3 ja, 4, 5 ja. So this will be 3 by 5. So this is the probability. Our next question is, it says that there is a bag which contains 5 red balls, 4 black balls and 3 green balls. Now 4 balls are taken at a random. This is 5 plus 4 plus 3, that is 12. So it says out of these 12 balls, 4 balls are taken at random. What is the probability that all balls are of same color? See, we have only 3 green balls. So this is excluded because we have to take 4 balls. We have only 3 balls. So this is not possible. If we take 3 green balls, obviously one ball will be of another color, so that is excluded. So it is either this or this. That is, we have to find the probability of this union this. Okay. Now we have solved so many such questions. I will write it directly. P A union B, or I am writing red union black. What it will be? Taking 4 balls out of 12 balls. This is from red and this is 4C4 12C4. And what about intersection? There will be no intersection when you are taking out 4 balls from black. They are only black. They cannot be red or green. Therefore, here a red intersection black is 0. We do not have any common ball which is both black and red. Intersection means that the ball belongs to both these groups. Can there be a ball which is of a red color and black color both? No, we have complete colored balls. So this is the probability, that will be 0. So how to find this? This is equal to factorial 5 by factorial 4 by factorial 1 plus factorial 4 by factorial 4 by factorial 0, 4 minus 4, 0, and this is factorial 12 by factorial 4 by factorial 12 minus 4, 8. So let's cut all the factorial 4s. Okay. Then what we have? This is equal to, it will be hectic. So let's not cut it. Let this be there. So this will be 5 cross factorial 4. So this is 5. This will be 4 cancel. So this will be 1. So we'll get 5 plus 1 in the numerator. And in the denominator what we get? 12 into 11 into 10 into 9. Factorial 8 gone. So this is 12 into 11 into 10 into 9 by factorial 4. That is 4 cross 3 cross 2 cross 1. 4, 3, 12. So this is gone 2, 5 times. So now what is this? 9 into 5, 45. 45 into 11. What is 45 into 11? That will be 450 plus 45. So it comes to 2 by 165. This is the possibility that all the 4 balls are of same color. 2 by 165. Okay. Our next question is, it says there are 2 events A and B. The probability of A is given by 2 by 5 and probability of B is 1 by 3. Also, the probability of A dash intersection B dash is given by 4 by 15. Question is, are A and B mutually exclusive? Can we find out whether these 2 events are mutually exclusive from this data? We have 3 data. See, we can get it. How? When will be the 2 sets? When can we say that the 2 sets are mutually exclusive? When A intersection B is 5 empty, then the 2 sets will be mutually exclusive. Let's see this. Let's observe this. This is PA dash intersection B dash. If you apply De Morgan's law to this can be given, and this is equal to PA union B complement. This is this, which can be given as 1 PA union B. This is this, and this we say this is 4 by 15. So from here we get PA union B, probability of A or B is equal to 1 minus 4 by 15. That is 11 by 15. But what is PA or B? It is P of A plus P of B minus P of A intersection B. So this is equal to P of A. What is it? This is 2 by 5 plus P of B. This is 1 by 3 minus PA intersection B. Therefore, PA intersection B is 11 by 15 minus, this is what? 5 3 is 15. 5 3, that is 6 plus 3 5 5, that is 11 by 15. So this is 0. Now probability of A intersection B is 0. This means A intersection B is 5. Therefore, the 2 sets are mutually exclusive. Okay.